Shreya, your mic is muted.
Yes, yes, mic is muted.
Shreya ma'am, you are not audible.
No, no,
No,
your
ma'am.
voice is not coming.
Okay. Good evening, everyone. It gives me immense pleasure. Nitin sir, please mute all. Mute all the participants. So, good evening, one and all. It gives me
Ma'am, can
immense.
you hear me?
Shreya ma'am, are you?
Can you hear me, ma'am?
Yes, yes,
Yeah.
you can continue. Yes, ma'am.
Okay, okay. I'm sorry. I'm sorry for the anticipation. Can I start now?
Yes, yes, you can start.
Okay. Yes. Good evening, everyone. It gives me immense pleasure to extend a heartfelt welcome to all the dignitaries and participants present for today's AICT training and learning. ATAL Online 6 Faculty Program 2025 to 2026 on Next Generation Manufacturing Embassy in Industry 4.0, organized by Sri Balasubramanian Shikshan Prasarak Mandal, Ashok Mane Group of Institutions. I am Ms. Shreya Anil Kubde, Assistant Professor, Department of AIDS and AML Engineering, and it's my privilege to anchor today's proceedings. Let me begin by warmly welcoming our esteemed dignitaries. I heartily welcome our respected Director, S.R. Chowgule ma'am, and I extend a warm welcome for coordinating this program, Dr. Seema Patil ma'am, Dean Academics A.M. Joy Vatar, and Coordinator, Dr. C.R. Dongalsane sir, HOD, Electronics and Computer Engineering Department of Computer Science and Engineering. I take this opportunity to welcome our two distinguished speakers, Mr. Arijit Chatterjee and Mr. Rajsekhar Uche. We are grateful for your virtual presence, sir.
Thank you.
Without further yes, without further delay, it's my pleasure to introduce our esteemed speaker for this session, Mr. Arijit Chatterjee, for the session C from Concept to Market Product Development 4.0. We welcome you, sir.
Thank you very much and welcome all of you for another interesting session today. Yesterday we discussed about the the one of the slides that I will skip today, which will be on design thinking, which is also part of your new product development. So
Yes.
to
Yes, sir.
start this, let me share my screen as well.
Sir, please 2 minutes, sir. 2 minutes.
Yeah,
Can you please 2 minutes give me?
yeah, please.
Uh, it gives me it gives me immense great pleasure to introduce a dynamic leader, a seasonal professional, and passionate for innovation and education. Please join me in welcoming Mr. Arijit Chatterjee, the Chief Business Officer and co-founder of Seacentric, a cutting-edge customer experience technology company that is making waves globally. With a nearly 3 decades of diverse experience across software development, R&D, the product innovation, sales, and global marketing, Mr. Chatterjee has held a leadership role in prestigious organizations such as Infosys and Schneider Electric. He has also walked the entrepreneurial path, founding his own edtech startup, further reflecting his commitment to meaningful impact to technology. An electrical engineer from BIT Sindri, an EMBA graduate from ISB Hyderabad, Mr. Chatterjee is a unique blend of technical depth and business acumen. At Seacentric, he leads a new product development, a global marketing and business growth, helping the enterprises transform the way they connect with their customers. Currently, he is exploring the exciting frontiers of AI machine learning, especially their applications in marketing and customer services, truly staying ahead of the curve. Beyond the boardroom, Mr. Chatterjee is deeply passionate about quality education. He is actively contributes to knowledge by sharing, conducting workshops, training sessions, and speaking at the various events, always emphasizing that education is a true catalyst for the nation's development. Please join me in welcoming a visionary leader and a lifelong learner, Mr. Arjit Chatterjee, sir. Over to you, sir.
Welcome, sir.
Yeah, yeah. Thanks. Thanks. This is a very long no introduction. I'm not that so much to be introduced like this. Anyways, so let's get started. Okay.
Yes.
So I'm not sure. Usually, in this session, we we take some input from the participants in case what is your expectation out of it. Okay. So if you guys have any expectation, because this is going to be something which is not typically covered in other sessions, okay, which is more from manufacturing. This is little broad-based kind of a topic, and we are talking about new product development. What should be the approach for bringing new products in the market? Okay, so if you have any expectation, you can use this chat. So, like yesterday, also I will recommend if you have questions, you can unmute your mic and ask the questions. Okay. If you want, you can use the chat now, and I can read the chat messages. So let's say now, if you have any expectation now, before we start this session, you can put your points on the chat so that I can pick them up when we go through the presentation. Okay. So yeah. So let's look at the biggest transformation that the world has seen. Okay. So this is just a snapshot of what the world has seen so far, and what will you see over here on this slide actually shows that most of this are completely new. Okay, these were not a existing product, and it was not a, I would say, enhancement of an existing product. Okay, so for example, when the first bulb was produced, or when the first wheels were produced. Okay, so it was not like it was no earlier there was something and then they were building things. So it was something that the world has seen for the first time. It was new introduction. Okay, so currently what we are seeing is the revolution with generative AI. Okay, so technically people will say that AI existed for few decades. Okay, but that's not the point. When was it become useful for the mankind? Okay, so that is the starting point of this presentation around new product development. That why new product development? Because they are creating the biggest transformation in the world. So what are the key drivers? Okay, so we know about invention and innovation. Okay, I hope now we know the difference of it. Okay, so invention is something that is created, maybe more like a scientific invention. Okay, but innovation is when it is a new product or new solution or new service is brought to a larger audience or larger consumers. Okay, so that's where the innovation comes in. So I would say in another way is that maybe invention is more from a scientific community, and innovation is more from the engineering or the I would say the community which is helping this kind of products to come to the market. Okay. So typically, when we talk from an engineering perspective, okay, engineering is nothing but the application of science. Okay, so whether it is the mathematics or any kind of science that is there, and engineering is more of applying of the sciences. Okay, so that means engineering has a big role to play in creating the new products. Okay, and that is where we are going drifting towards the main topic about new product development. Okay. So what does this new means? Okay, product development is product development. We know that we are talking about developing a product. Okay. What does the term new means? Okay. The new happens in multiple times in our environment, in our ecosystem. The one is that a new technology is arriving, okay, or a new standards has arrived, okay, and that has triggered to create a new product. Okay. There could be another is that a market, okay, which was not there, okay, has been created, okay, say like the social media. Okay. So it was a market that was created, if you see, okay, because the it's not a new set of people that came into the existence, okay, to use the social media. It is all of us, okay, but it was not there earlier, and there's a new market has been created, and now we know that it is a booming market of social media, and it could be new to the company. For example, my company is not into say a set of product or solutions, and we want to bring a new product, okay, catering to our customers or a new set of customers. So these are the three, no, I would say classification when we say our new product development. So it can be, it is not that new means that it has to be completely out of the blue, something never done, never, people have thought about, and we are all guessing the new product. Okay, it is not necessary. Okay, so however, it is not a incremental improvement. Okay, it is not like no, I have the car is there. I'm just increasing the fuel efficiency of the car. Okay, that is more of an incremental improvement. Yesterday, like I was talking about valves and how do I incrementally improve the performance of the valve. Okay, which is not typically gets into the new product development. It is an incremental development. So these are the things that we will cover today. Okay, so we will talk about introduction to product development, understanding customer needs, what should be the new product strategy, okay, organizing product development and various stages of product development and how we create new products. Okay, okay. So just let me know if you are aligned with this agenda. If you have some other things that you want to be covered, feel free to put it into the chat. So why this project or this session will be useful is that as a as a part of this session, if we can create trigger ideas and approach to create new product or services, okay. So you are involved in maybe numerous different projects, activities, or associated maybe with industry as well. So after this session, if the best outcome will be that it triggers ideas, okay, and how to create it, okay. And second is that applying this knowledge in your maybe a new job that you are taking up or a new project that you are taking up, okay. So this is typically the expected outcome if I consider the topics that we consider, we will cover. This kind of outcome we can expect, okay. Okay, so need of new product. What is the need? Okay, so one is the risk to business. So if we are not creating new product, okay, somebody else will be creating it, okay. And if that somebody else is your competitor, then it is a big risk to business, okay. Second is revenue growth. So every company will come to a stage where the revenue is not growing like it was growing earlier, right? So it stagnates, okay. So that's the time when the organization has to bring a new product to generate more revenue or grow their revenue, uh, for the next, I would say, cycle. Providing more choice to customers. So customer, as we all know, we are all customers as well. That customer have a, I would say, a uncanny desire to have something new. Okay. So even if you go to a restaurant, he will say that, okay, these are all good, but what is new here, right? So we are always in that, seekers of some new thing. Okay. So that's why customer as needs new choices to be provided and something new from a product perspective. We have to look at something new to be brought to the customers also, If you are meeting your customers, no, you will also listen, hear them. Okay, we know about your offerings. What is new? Okay, what have you done new this year? Okay, and obviously the business expansion for the from a business perspective. Okay, that is no, very critical, no, important. Linked to the new revenue growth, you want to expand your business, you want to enter into a new market. We are operating in, say, a particular geography, want to enter into a new geography, and the new geography may not be suitable with our existing product, and then they will be in demand of a new product. So the birth or genesis, how this product development, right? We are talking about product development. So we talked about technology side, okay? So technology, as we know, is evolving. Okay, so if you look at transistor, which just I would say disrupted vacuum diodes, and the electronics, I would say innovation started happening rapidly with the introduction of the transistor or solid state drives. Okay, from hard disk or from internet perspective or from manufacturing currently, for example, electric vehicle. Okay, so these are all technology breakthroughs that is bringing the new product, right? The other, which is also very important to understand, is underserved or unserved market. Okay, so when we are talking about market, okay, doesn't mean that it has to be a specific geography. Okay, that it is now Asia Pacific as a market or Africa or South Africa, no, sorry, South America as a market, but it could be a category in the market, okay? Say the privileged guys or the underprivileged guys, depending on what kind of product we are talking about. So there is a market for everything, okay? Only is that and I will come to the product market fit as well. So the point here is that when this market is not served, okay, then there is a need to create the product, okay, a new product or introducing a product to serve that market. But it is important to understand whether the market is sizable enough, okay, whether that market will be able to afford the product or service that we would like to provide, okay, and whether there's a limited providers, okay. So that means there's another opportunity for a new player to enter. If it is already a crowded market, okay. Obviously, if it is a crowded market, it means that the market is already served, okay. So it's not a unserved or a underserved, okay. So when we are talking about this, okay, remember, I am always classifying it as a product, okay, but it is not limited to product. It could be product, it could be solutions, it could be services, right? So it's all about it, but just for convenience, every time I cannot tell product development, solution development, or service development, we'll keep it as product development as the term. Okay. Another factor that business companies take or any entrepreneur will take is to look at whether there is a niche in the market specifically for a specific application that product does not exist. Okay. And for example, if you look at now, say a CRM solution, okay, a software CRM solution, okay. The CRM, generic CRMs are available, but for example, for a clinic or a spa, okay, is there a CRM? And if there is no CRM specifically for a spa, then you get a niche, okay. That niche means I am going to cater to only this kind of organizations, okay, not a very generic solution. So these are like, if I find out this is a unserved market and we can create a new product for this market, okay. Some examples just to reflect upon, okay. So when we are talking about new product, okay, when say iPhone was introduced, okay, it is not that people did not have phone at that time, okay, but obviously it was a completely revolutionary, okay, in all the aspect. I will not get into the detail of iPhone, okay, but just to show that or re-emphasize that how this new product or Paytm, for example, Indian solution, which came and it was not there anything else before that, right? So we never figured out before that we can do transactions, we can make payments, we can do all the things over a mobile app. I will not get into too much about innovation. There are other slides to cover. So some of the slides I will just skip for the reason that we have limited time for this session, and which may be taken in next module or any subsequent module where we can deep dive into it. Okay? So just for for academics who may be interested, this is a very good book, The Innovator's Dilemma. Okay. And what this book essentially, this book is a whole lot about innovation, okay, and about new products. But what it says that every innovation or goes through a S curve, okay. That means the technology goes up and then it comes to a plateau, okay. Beyond that, it is not growing further, right? And that is when a new technology comes, okay. So that's what the author has explained is that if you see there are three tech we are talking about: cassette, CD, and MP3. Okay, most of us has gone through this life. Okay, where we had cassettes. Okay, there was a huge surge in cassette industry. The T series industry was completely know uh, their growth was mostly powered by the cassettes. Okay, but at this time the CDs were not very popular. Okay, and it was not very convenient and it was expensive also. Okay, but slowly then the CDs came up. Okay, and this is where when the CDs were plateauing. Okay, there was another technology which was coming is the MP3. Okay, which means that everything can be transmitted. Okay, easily on internet, and that's how it started with. So now, if we are standing somewhere here or with Spotify and other things, we are slightly above on this. But if you reflect back, okay, would you go back and take the cassette now or a CD now? Okay, obviously not, right? But they have lived their time. So in the time horizon, sometime it was very, very, the most sought out of, and somebody started creating the new product. Okay, so this is a very interesting S curve. Okay, and you can reflect back, later on also and think about the S curve that you have seen in other industries also. And there will be obviously this thing which will be coming. And most of it is because a new technology is powering that. Now coming to new product development. So this is so far what we were saying is that the need, why a new product development, what triggers a business or an individual to introduce new product and other things. So we have come to that point. Okay. Now let's look at what are the building blocks of a new product development. So tomorrow when you are responsible to create a new product, okay, what are the building blocks that we has to be taken care of? Okay. So first, obviously, is the idea generation. Okay. We'll come to all these things as we go ahead, showing with some examples how it is done. Okay. So idea generation. So as you know that that's the starting point. Somebody has to have an idea, a team, set of people who has to have some idea. Okay. Then those ideas has to be screened. Okay. From a feasibility perspective. Okay. So we have several ideas. For example, how do I improve, or how do I say with the power of AI currently, right? How do I create something which can improve the performance of a product, or improves the overall cost of ownership. Okay, so let's imagine some of this idea is in your mind. Okay, so you have to come up with okay, this is the kind of a solution that I will be building. Okay. So, but you may when you are sitting with a team, okay, it's a collective work. So you will have multiple ideas coming at this time. Okay, and it is not like yesterday when we were talking about design thinking, where we are improving is the process. Okay, here it could be that it does not exist at all. Okay, Okay. So in that case, it may not be easier to go and do that customer survey, understanding all these things. So it all depends upon what kind of idea you are going ahead with. Okay. Concept development. So this is very essential because at this point of time, you are not sure how much the investment will be required, no, how you will be, showcasing this solution to a small set of, potential users or to your investors. So you have to go and build a concept. So concept can be a mock-up or something that is working. Basic functionalities are there, a prototype, right? Then comes that, yeah, okay, the concept is being accepted. Now you want to go and scale this, okay? So at this time, you will also parallelly start working on the business strategy, okay? Business strategy is not only about, generating revenue or business plan, but how do you go to the market? What is your strategy in, getting new customers? How do you fund your business, right? What kind of growth the investor will see, if he has to invest. So all these things will come on your business strategy, okay? Then comes the product development, okay? So you are now going ahead, you have raised the necessary fund, you have got certain kind of strategy to bring this product to the market. So you're building the product because the prototype has already been created. This prototype is now getting tested, okay? So you have a potential users who will now try and test the product. And there can be multiple iteration where the test says that no, you have to improve further, you go back to the prototyping or you go back to the design phase. And then at one point of time, you come up with a commercialization that you want to launch this product. In most of the industries, they have the several versions of the product released. Okay, software is very common. Even in hardware industries, no, there are the prototype and then the version one, and then successfully launch the final product, right? And introduce this. So if you see, this is a cycle, okay? And this, irrespective of whatever product you are into, okay, if you have decided that we will have to create a new product development, this path has to be followed. Okay? So this is irrespective of the industry. Okay. So just type NPD if you understood the new product development cycle, so that I can get a feedback and I can move forward in the next slides. Okay. So is this clear, guys? I don't know why everybody is so silent. Okay. So no, feel free, because today is a learning day. Okay, so feel free, ask question, interact over chat, and I always tell you, as a learner, asking questions is another way of probing the thing that whether you have understood the things. Okay, so don't hesitate, bring it up. Okay, and also you can suggest if you see something is not covered, okay, because it is all these things are coming from my practical experience of creating new products. So there could be obviously there are others also doing the same, and they may have figured out that okay, there are certain things that need to be added also on top. So so here as I was saying that there's a process that is followed. Okay, now why to follow a process? Okay, basically many times what happens is that there is a gut feeling, okay, that yeah, I think people need this product, okay, or this service. Let's go and join hands and start building something. Okay? That's good, okay, but that is not how you go into scalable growth. Okay, that is good as a beginner in as a want to do, you're in college, just passing out of college, you want to create something, but proven is that you have to follow a process which is very, I would say rewarding in itself. Okay. So, for example, if you do overestimate market size, for example, when we talked about the idea, okay, and then the size of the market, the idea is fantastic, okay, but how many people will be paying for your product or services, right? So that could be one, area to look at that, how big is the market, okay? Customer requirement, okay? So have I understood the customer? No. Many times we as a customer have felt a problem and then we are trying to create a product or services, okay? That means I as a customer understand it. But a lot of times when we are building product, we will not be the consumer of that product, right? So understanding the customer requirement or getting it misrepresented, misinterpreted could be devastating, okay? Launched at the wrong time, okay? So if you are not following the process, you may be jumping the process and launching it at the wrong time, right? Poor product design, price too high, poor advertising, marketing, high product development. Competition is there. Have I evaluated the competition? What are the risks? What are the threats? Okay. So these are all good things to avoid. And to do that, following a process, which I was saying about the new product development process, it's a good idea to apply this. Okay. And if you do not, okay, because remember that we started from scratch, okay, we may have taken some investor money as well, okay, to build it. And if we are not doing it, it's not that we, new product development will not pay, okay. It will, there is a high possibility of it pay, and then you have to pivot, okay. But the risks are very high for new products because if you do not even follow a process, then we are in a very risky zone, okay. So ideation and design thinking, I think we have covered this. So we will just quickly go through ideation. So ideation, there is the scamper model is there. There is the design thinking process we covered quite intently yesterday. Okay, just a minute. So I will yeah. Anybody has a question? Yes, madam, tell me. Hello. Okay, I think accidentally the mic is on.
Yes, sir. Yes, sir. Accidentally, might be mic is on.
Okay. So we will not get into the ideation and design thinking because that's the first part of this process that we talked about. Yes. And uh, if you see this ideation, idea screening. So we discussed yesterday all these things. So we will skip it for today. But what I will come to is the customer and market segment. Okay. So this is where from a business development and strategy, okay, you may definitely need this section. Okay. Um, since this is more the theme is more from manufacturing, so I would like you to emphasize this aspect because again, now being an engineer, I always felt that I always saw that it is like an engineering problem that we are trying to solve, okay? And not look at the customer's point of view, okay? Or customer, challenges the customer. So many times we do not know who is the customer even, okay? So identifying the customer persona, serving their, different ways. It is not always that you go with a survey sheet with them. Observing those customers, understanding the pain point, building relationship, okay? Check with your support team, okay? What kind of, concerns are, uh, just a minute. Kindly mute the mic, otherwise it will be,
Hello, Ekta ma'am.
yeah,
Ekta ma'am, please turn off your mic.
okay.
Okay, sir.
So, what customer needs, okay? So this is very, very, intriguing questions for all of us because everybody wants to know this answer, okay? Because if you know this answer, maybe you can start working on the correct problem, okay, or correct solution. And knowing this is very important for any kind of business owner or any kind of companies to ensure that they are doing the right thing to while building the new product. Okay, so customer could need about functionality, price, convenience, experience, reliability, performance, efficiency. Okay, so obviously when we are in our domestic market, okay, prices are always a big differentiator. Okay, so anything that is if you're taking all these things, but price is on the higher side, okay, maybe that product will not get a much of acceptance. And but this is changing in India as well. Okay, we are seeing premiumization happening. Small, I would say tier 2, tier 3 cities also now looking for premium products. Okay, so it's not necessary that no price is always a concern for customers, but value for money is what the customers are looking for. Okay. So this is like some customer survey you do, okay? Market research. So market research is uh, today it is very easy to do market research with the help of Chat GPT or Gemini. Okay, you can con- ingest a lot of data very quickly, okay, to understand what segment, what is the size of this market, okay? How many people would be, this kind of a population that you're, targeting, okay? For example, you are looking for urban household is, earning a salary of uh, say 1 lakh a month or something like that, and you see that this is not relevant for your product or offering, right? So you can quickly, do that. Otherwise, it has been very difficult to do this new part, and companies will invest with certain agencies. Okay, so there are market research agencies who provide it all this information, so that it will be important to know is it attractive. Okay, the either is the market attractive, or shall I change the market segment or look at some other segment, or what is the growth of this market, right? Yeah, it is good, this market requires it, but we know that this segment will not grow, okay? Or it will be like, if you are looking for, say, young couples in a matured market, okay, advanced market, that population is not growing, okay? So you can understand what is the growth rate, what kind of pricing that no market is expecting, what kind of competition is no this market has, right? So this is part of your business development activities, okay, and part of NPD, okay. And you cannot just avoid this because this is very important. Because if you make a product, right, what is the purpose of making a product, right? You would like to ensure that the product is being used by more consumers. There's more revenue, there's growth from a business perspective, right? So knowing the market size is very important, right? If the market size is small or it is not growing, okay, already there are too many players, right, into the market, right? For example, today, if you see the telecom industry, okay, so is it a good time to enter as another telecom, okay? Like already Jio and Airtel have not taken their position, and you want to enter into the telecom market. Is that right? Right? Is it attractive? Okay. Can you provide a price which is lower than what Jio is offering? Right? These are the questions to ask. Okay. And say, okay, my market research says yes, it is. There's another opportunity for a third player to enter. Okay. But the third player will not go through the conventional towers now. Okay. It will come through the satellite. Okay. Through Starlink or some other no approach. Right. And what is the cost to it? So it will be expensive. Okay. But will people need it? Yes, some no, people will require it. So these are the things that goes on in doing the market research. Okay. Segmentation. So when we talk about market research, it's very important to understand the segment. Okay. So segments, so we'll not get into too much detail about the segments, okay? Just to understand that there are four or multiple types of segments, which could be geographic, Demographic means kind of age-related, psychographic, kind of, people, who have different kind of, psychological needs, okay, or behavioral, right? Just giving you example, demographic could be age, education, income, family size. Behavioral could be purchase, consumption, or their lifestyle. Okay. Psychographic is again to do with their personality traits, what they value, what is their opinion, and geographic is obviously the based on location and their needs. Okay. So when we do this market research, we will definitely have to get into this market segmentation. Okay. So for example, there is definitely the market segment for a big bazaar, okay, or DMart. So big bazaar is not no more there, okay, but DMart, okay, is there, and we know that this segment is a specific segment that DMart is catering to, okay. And interestingly, if you see that with the introduction of Blinkit and Zepto, okay, they had a bit of challenge with their segment that they were catering, okay. And DMart also, started heavily on the quick commerce. Okay, so that's another discussion to have. But just to understand that each businesses have their own market segmentation that they do. Okay, so that they are, very, very, laser focused in that segment, and they become clear winners. Okay, this I can give it, but this is again, a very scientific paper. Okay, which talks about this BCG. BCG is a company which created the BCG metrics. Just to give you an understanding that if you see that as a business, okay, you will have either in this quadrant in terms of market share. As a company, you can have a low market share or a high market share. Okay, or you can have a growth rate if you see of the market, right? It could be high or low. Okay. So if you see this box, the first quadrant, okay, the market growth rate is low, okay, but I as a company have a very high market share in this space. Okay. So this is basically my cash cow. What it means, if I have a very high market share, that means I'm almost having a monopoly, okay, or duopoly or whatever, right? I'm one of the leader in the market, okay. But market growth rate is not growing very fast. Okay, so this is a cash cow. Okay, similarly, there are other no, I would say quadrant. This quadrant is very interesting. Okay, that the market I do not have a uh, as a company I do not have a big market share. Okay, I'm introducing a new solution. Okay, but I do not have a big market right share. But what I am seeing is this the market growth rate is projected to improve. So, as I said about the market research, right? So, market research shows that more and more people will be using, say, um, mobile phones or AI or anything. So, it is that there's a huge growth in this segment. Okay, and I am here. Okay, with a lower market share. So, for me to move from here to this is what every organization is looking for, okay? Because this is going to ensure that we, or as a business, we enjoy. Because if I have a bigger share and the market is growing, okay, so you know that no, it is a booming thing, okay. Both the sides I am now winning. I am having the market is growing and my business is also growing, right? In terms of having a larger market share. Just these are all various derivative of the same thing about market research that I was saying. Okay. So before jumping into a new product development, these are very important things that has to be analyzed. Okay. The next is the product market fit. Okay. So this is very much discussed in the startup ecosystem. Whether you have a product market fit. Okay. So that means the business or the entrepreneur or whoever wants to bring the product, okay, has to check that if the product and the customer, okay, the value proposition, whether the distribution channel, customer needs are all aligned or not, right? That means if there is a product made and there is a market who is willing to use that product, okay, that fitment is a clear recipe of success. Okay. And to explain that from this, so if you have a product, the right product in the right market at the right price, okay. So this is kind of holy trinity, okay. That if we are able to do this, okay, or even in nearly figure it out, right, that the power market is looking and this is kind of price. So fine tuning this is required. This is where the pivoting happens, okay. But this is where everybody wants to be, okay. For example, you create a product in this area which is not aligned with the market, okay. Or product or market is aligned, but the price is no, so there is no consumer in this area, right? Any of this overlap area also, if you are there, right, it does not make much business sense unless you are at the intersection of these three. Okay. Now let's get into the new product, this strategy. Okay, new product strategy. Okay. So we talked about the business market fit, but we have to have the strategy. How will I win? So what is the strategy? Basically, strategy, you plan to win. Okay. Strategy comes from the from the time people went for war. Okay. When they went for war, the king or whoever was leading the army, they will plan, okay? And that is when they strategize because the war is not happening. Okay, you are strategizing how you will enter the fort, you will enter the kill the enemies, okay? So in business world also, business is deriving a lot of things from those times. So there's a strategy, and the strategy is to plan how do I plan to win, okay? So so now in your strategy, it's very important. It should not be vague. No, what are you going to offer, right? How are you going to offer? What is your priority? Okay. What specific product service will I achieve? Okay. And then execution. How do I execute it? Okay. It is just not a paper thing that you have to create. You have to create the plan of execution. Okay. The strategy. Okay. Let's to understand this strategy. Let's understand. This is a very interesting, very old concept, okay, by Michael Porter. Okay, he was like one of the marketing gurus, and he brings a very interesting thing is that there are five forces that are always not any product that you are going to bring in a market, or if you are existing on a player, you will sense this five forces. Okay, so one is rivalry among existing competitor. Okay, say like Pepsi and Coke, okay, so they are having an existing competitor. There's a huge rivalry going on between them, okay. Then there is the external forces, okay, like bargaining power of buyers, okay. So if buyers have a very strong bargaining power, okay, then the market is not very expensive, no, attractive, because buyer cannot say that I will buy it for say say 10 rupees or 5 rupees. So they cannot make those demand. You will not have that advantage. Okay. Similarly, on the other side is suppliers. Okay. If supplier is like Intel or Nvidia, okay, who have the higher bargaining power than the product developer, okay, then it could may not be attractive because tomorrow you may have a challenge coming from the supplier. But it is not that everyone has to be green. That bargaining power is less for the buyer, supplier. There's no threat of new entrant. There's no threat of. It will not happen in life. Okay. Only thing we have to see the tension between all these five forces. If all these five forces are against, okay, then obviously it is a big a red flag to enter into this new product, right? But if the forces are relatively weaker, okay, or there are certain advantages, okay, because there could be, we are talking about this product for existing players like Pepsi and Coke, right? Now Geo comes in the play and Geo is coming with Campa Cola. Okay. So Geo is basically here. Okay. And it is creating a threat for these existing players. Okay. So we have to understand that, yes, now if you as a Geo, how do you see the scene? Okay. Do you see the market is attractive? Do you see these things are playing? Okay. Do you want to enter into this ring? Okay. So when I was talking about this strategy, okay, you have to have that clarity in mind. Okay. It is just not creating another faster no car, okay, or a faster no, or a valve or a no, pump, okay. But you have to understand all these dimensions, which will be part of your new product development approach. Okay. I'm jumping. There's too much of detail actually. No, in MBA, this takes 1 or 2 days also. Okay. We'll get into, we'll skip this as well. So what this slide basically says that you could be a cost leader, okay, like Amazon, right? You can be a cost leader, right? Or you can be a differentiator, right? So that means you do not prioritize, the cost aspect, but you prioritize the specific, differentiation that the customer is looking for. So as I said about the market segmentation that time, right? Market segmentation, you have to consider where do you want to focus, right? But you have to focus in one of this. You cannot say, okay, I want to be a cost leader and I want to be a differentiator also. So that means their clarity is not there. Okay. So these are very important. Some examples to bring in front of us that what this and these guys have driven that in that axis they have moved their business. Okay. And that is why they have been so successful because they have been focusing, their strategy is completely aligned on this. But a lot of companies are not there, okay? And there are a lot of companies sitting somewhere in the middle is not as successful as what Apple is doing. Okay, okay, this is too busy a slide. I will not get into this. Okay. So it's just about competition analysis. Okay. So now it is also important to understand that if you are introducing a new product into the market, right? How does the competitor looks like, right? What is their SWOT analysis? Okay, strength, weakness, opportunity, and threats, right? So these are all the exercises that one has to do apart from the engineering or the innovative idea that we brought and the prototype that we are creating, right? It may not be that the same guy is doing all these things, okay? So that is why I'm saying that a team is always good, okay? Because some people can focus on this, some people can focus on the tech part of it, some can look at the supply chain part of it, right? So it's a team that will help, but avoiding this that no, I do not have anybody to do, let us just create the new product and no bring it to the market is suicidal. Okay. This is something that should be in my product strategy. Okay. What is my product going to do for which market? What is the scope? Do I want to be a cost leader? Do I want to create a differentiation? What is unique in my offering, right? These are all the questions that needs to be answered as you dwell into the world of new product development. Okay. Now we come to the interesting part. I think we have some more time left. Okay, guys, any questions, guys? I'm speaking for a long time. I'll pause for a moment. So,
Sir, can you guide us for any service kind of business? Not for the product, but any kind of service business. Means how
right.
to get the mentorship and the funding also.
Okay. Can you give some example about services? What is in your mind?
Means any service like suppose if I am a barber in the barber business, then how we can improve that?
Correct. Okay. So I got it. So today, if you see in India, okay, there is very less of product coming in and more of services coming in. Okay. So let's say the Ola, or which is now a copy of Uber, okay, is nothing but a services. Okay. So how do you get car hailing services or no ride hailing, no sharing services. Okay. Or today, for example, a Zomato or Swiggy or no all these companies, they are all what they are doing. They are not typically. I know that no, people will question that yeah, there is a product. Okay, there's a Swiggy app or all these things. But primarily, it is a service that they are offering. Okay, fast, less than 10 minute no time to delivery. Okay, efficient no delivery of the same product. So we are buying the same vegetable going to the store. The the same vegetable is coming to my home. Okay, and what they have just leveraged is the supply chain. Okay, how do I know? So if I look at most of the things recently that we are all enjoying in life is more of a service driven. Okay? Now, the same thing, as I said, applies when you are creating the services. Say, for example, you were the founding member of Swiggy, okay, or Zomato guys, right? Link it. You would bring up all this discussion in your team that let us understand the market, right? What is the size of the market? Which market should I cater, right? Initially, when they launched, okay, they were saying, hey, grocery and all those things, only people who are living in high-rising apartments will be the guys who we will target. So initially, the not even tier one city. In tier one city also, they were finding areas where people have a higher density population, okay, and living in societies, not smaller ones, the bigger ones, because they know that these people will like to use these services, right? So if you see the market segmentation that they did also was on the same lines, okay, where to focus, which type of customers I should focus, right? So we talked about the segmentation, right? So if you look at services, services essentially has the same thing that so for example, you are talking about a barber, right? So today, for example, a salon as a business is a very, very attractive business because people are having more disposable income and they are willing to spend on their beauty, okay, on how they look, right? So, so now this is a service. Now, if you see, there are salons, okay, already, and there were salons already. Okay. Now you will see that there will be new types of salons that are coming in, right? Which will give not only efficient services, but services that were not there existing. Okay. So now if you are a salon or you want to get into this, you will have to go through the same approach. You know that there are competitors available in the market. How do I position my offering and beat the competitors, right? So in general, as I told from the beginning itself, I am just using the word product, okay? But don't get me wrong, the product examples are easier to know
Yeah,
relate,
yes, sir.
but it is just one and the other, okay? Whenever I'm saying product, you can just delete it and say services, okay?
Yeah, yeah.
Okay. So product development upstream. So we talked about this, okay? So now we'll get into the stages of product development, okay? So these three things we were talking about upstream, okay? Mid. So I've just made it like this so that we understand it. So far we talked about market research, competitor analysis, customer insights, and kind of a business plan, okay? That what are we going to do? How much it will know my cost to do it, right? What is my business plan? What is my strategy? How do I get into the market, right? Then we get into the product, okay, or solution or a service. What is the requirement, right? How do I cater to this requirement, right? So, for example, it could not, it may be a no a service that we are talking about. Still, you need to have this in clarity in mind that how will people consume my service? Whether I will create a mobile app through which people will consume, okay, or there will be a kiosk, physical store. How do the people will consume my services, right? So you will have to create that product designing, or the wireframing. Okay, if it is software, you need to understand how it will, interface will look like, how it will, customer will be engaging with the solution. Okay, at this time is also because from the upstream we have, got the understanding about the pricing. Okay, so what is the pricing? What is the competition? You have done the SWOT analysis, right? So we will have to have some idea about the pricing. Okay, the project management delivery. So we are building a product, or even if it is a service, if it is a salon spa service, right? You will have to have some infrastructure, right? Some you need to hire, you need to have, invest in capex, you need to have a team, you need to have the infrastructure, software, everything. So you need the project management and delivery to be in place. If it's a product, physical product, or no any other kind of product, so it has to be tested. Even if it is a service, if it is a delivery, you have to test it whether within 10 minutes the guys are able to deliver or not, right? What are the challenges they will be facing in doing this, right? So product testing and all those things. This goes in the midstream till the point that the product gets launched. GTM is a short form of go to market. Okay. So how do I launch the product? How do I advertise this product? How do people know about it? Do I need a distributor channel? Asian Paints, for example, had a very interesting way of, reaching the end customer without the distributor in place, right? So there are, now every organizations will have to figure out how do I go to market, right? So this is the second part of it, which is the midstream. Okay. And the third part is the downstream. Okay. Now the product is already reached to the hand of my customers, right? We are facing some field issues, okay? Or whether my product needs evolution. So you have launched the product, it is no 3 years, 4 years, whatever is the life of the product, right? Then you need to, or if it is a service, right? You wanted to cater X thing, as I was saying about Swiggy and the guys, they said we will cater on to premium of premium, customers, tier one, and that too, people who are in high dens, high rising, complexes, right? And then now they are saying that we are going to tier two cities. Okay, so that means is the same model going to work in tier two cities? Obviously not. Okay, because tier two cities may not, because say for example, today in a high rising building it is easier because you get a dark store and you can commute easily. But in a tier two, there are small houses scattered, right? So the same model, they have to re-engineer the entire thing, right? And then as the product comes to obsolescence, the technology has changed. Nobody is now willing to go for a petrol or a diesel car. So more means India, it is the story is different, but in European market, more and more obsolescence it is going through, and people will be more pivoting towards a hybrid or a electric vehicle or any kind of renewable energy and other stuff. So the product which was so popular, so I would say having a huge market share uh, is slowly going to degrow. Okay, and that is where the product obsolescence comes in. Okay, again, this is quite vast. I'll leave this business plan. Okay, so now going forward, when we were talking about the strategy, we get into the business plan. Okay, so this is some to some extent I've already covered, but these are very important aspects, right? Financial projection. Okay, because many times we do not know, okay, we'll make this product, okay, let's see how to, even if you are talking about a service like a barber shop, okay, you have to have this kind of a financial clarity. Okay, what is the top line, how much of the revenue I will be generating, what will be my cost, what will be the breakup of this cost, right? What are the revenues, okay, how much is the profit, how much will be the taxes, okay, how much is my marketing expenses. So this kind of clarity, I am telling you that being an entrepreneur multiple times, I have realized that this kind of clarity we lack. Okay, we are usually carried away by the idea of building a product, right, or providing our services. But when you look into this and you say, okay, the numbers do not look very exciting, okay, or interesting, right? So should we really get into this? Or how do I reduce my cost looks very high, okay? How do I reduce my cost? What are my alternatives, right? Go back to our tech team and discuss about this that no, if I use a GPU in this, no, it is going to be super expensive, okay? So what is the alternative? Can it be done by CPU? Okay. So this kind of questions will come, okay? And this will only come when you have put up this financial projections in front of you. Not having this is not an excuse because you cannot say, okay, at this time we do not know, okay, when time will come, we will build all these things. Let's focus on the product, right? So that is, I would not recommend a good approach. Maybe you do not know those details so granularly, okay? These numbers will evolve further, but you should have some indicative numbers which at this point of time you are aware about, okay? So we talked about this market segment competition pricing go to market, okay? Sorry, pricing go to market, okay? How do I reach to the market? So remember in the NPD we had this slide where we were talking about the go to market approach. So is this clear in our mind, okay? So distribution channel. So go to market is nothing but how do I reach my product or services to the consumer, right? So, for example, if you are making cakes, okay, or breads or biscuits, cookies, right? So this is also for them equally important that how do my product goes into the market, right? Shall I sell this online, okay? Or shall I, work on with the supermarket, right? And place my product in the shelf, right? Which supermarket should I focus? Okay. What will be the logistics to reach to those supermarket from where I am building those cakes or bakeries? Okay, so these important under aspect, right, needs to be validated, needs to have the clarity in terms of whether that supermarket is already crowded with more cakes. So should they be the right consumer your channels, right? I'm just giving you an example. Okay. It could be for other products, the distribution channels can be completely different. Okay. For example, you're making a electric tractor. Okay. So your distribution channel will be completely different. Okay. You cannot you can say that okay, I will make the product and I will sell the product also. Okay. Sounds okay, but it does not sound scalable, right? How many products can you sell, right? You may have two, three people, four people, salesperson. Okay, they will go to the customer and try to sell it, right? That can be in the early days, you can try it out. But without a proper distribution channel, you cannot pan out your solution to a larger market segment, okay? Let's look at the product, development, the process, okay? So this I'm telling you is the Kano model. This is very simple to understand that one aspect, what customer wants is the functions. Okay. For example, if you are building a clock or a watch, okay, its basic function is that it will show you the time accurately. Okay. So that is one dimensional, that is the desired quality. Okay. This should be measurable. Mostly these are the things that people mention, okay, when you talk to them or you have been a customer of some other products and you have figured that there's a gap in the offering, right? So this is very important. That is the one dimension, okay. The other is that it could be so first is the no the must be, okay, and then you see the delighters, okay, something that customer may find delighted. If you give a sunroof or moonroof, customer will be delighted. Okay, no more now. Earlier it was. Now most of the car manufacturers are giving it by default because now customer it has come to the straight line now. Okay, it has become a must have. Okay, so this is mostly unspoken, not mentioned. Many times customers also do not know that this they are looking for it, right? So you'll see, so the more you add this, okay, your growth on the satisfaction curve is going to, increase, okay? And more you, the expected quality, the more you reduce those things, because you say, okay, I have to cut the cost, okay, I cannot give all these things, I have to drop it, right? So more you take off those must be's, okay, which was in the expected quality, you are more likely to dissatisfy the customer. So again, this is applicable to product and service both, okay. What is very important is, uh, essentially we all know this, huh? If we do not put it in the graph format, we all know this. We are making a product, we know that no, these are the things that is required. But when you start doing developing your product requirement document, right? Then when you are list down the features, okay, you have to plan it out that what is essential, what is non-essential, okay? What are must have, what are the delighters, okay? So then you say, okay, if I want to hit this price point, can I remove this delighter, okay? Or if I reduce this further, whether customer will find my product any more interesting, right? So this exercise is part of your product requirement. So I'm slowly getting into the product development, okay? Uh, but I have less time, so I will skip some of the slides, okay? So product requirement is your blueprint, okay? Where you have to write the features, the various use cases, flow, the design, right? So this is your PRD, product requirement document. This is your Bible, okay? This will drive, or for example, if it is in services, okay, you have to have this blueprint in place, okay? Because your all decision of product development will be derived from this PRD, okay? If you make a very weak PRD, if you say, no, no, we do not have that clarity, you write 1 page or 2 page PRD, and then you start working on it, you will find enough frictions, okay, because the team does not have much clarity now. But if you invest a lot of time in writing a very, I would say, detailed PRD, then for everything there is a clarity in their team. So they do not. So it's like building, making a building, right? So you can make a building, you can get some bricks, and you can just put some walls and you can start constructing. But if you want to make a high-rising tower, okay, you need to have that architecture in front, right? So that blueprint, right? So for same thing in a peer or for a successful product, you need this blueprint, okay? Some sketches, some wireframes, all these things will be required. This is the pricing side, which is part of our previous discussion, okay? Now coming to the product development. So I'm just relating it because this is from a software side. It could be from any other side. It could be services. So what this slide actually telling us that you have to have a development process, right? Manufacturing, prototyping, all these things will go through a process, right? Then there's an architecture, okay? How will be your architecture, right? How will you build it? What kind of architecture you will be following, right, in building it? Then is the team, okay? You need people to deliver, people to build the product, right? So what kind of team you will be requiring, right? So the development process in terms of software could be agile, SDLC, whatever process you will be following, right? Product architecture, whether it will be what kind of security has to be placed, what kind of certification has to be done, whether it is on-premise, cloud, and other things, right? And the team. Then you have to decide that you have to do a UAT, you have to do a beta, you have to do a product rollout, right? So this encompasses the actual approach about the product development. Now we have, so far what we have done is we have done all the upstream work. Now we are in the middle stream, okay, where we are building the product, right? So building the product is very specific for what kind of product or services you are building. But essentially, you have to cater or you have to take care of the product development phase. And then you launch the product in the market, right? What kind of events, what kind of so promotion I do, how do I call my customers, prospective customers, marketing and other stuff. Now, this is very important to understand the product diffusion model, okay? So when we are talking about any new product, okay, you will see that this is the path it will take, okay? So initially, there will be very less takers of your product, right? So this is called the innovator side. And then you will have early adopters where people have started taking your product, right? And you will see this also with services, okay? So if you see the the recent evolution or innovation that we have seen is the quick commerce, right? It was there, but not many of us were using a solution like Blinkit or Zepto and other things, right? So they have seen the consumers who have moved from this space to this space, okay? Now, good part is that as a product company or a service company, if we are able to hold to this stage, okay. So if you see that as your early majority or late majority is adopting the product, the market share is also improving. So this is typically this applies. This is a proven model, right? As the adoption increases, the market share also starts improving. Okay. And then, it is showing that more and more the laggards who not even use the mobile app has also started using it, right? That means these people, if they have started using it, the market share is nearly 100%. We are talking about the reach of the market share. And as this is the maturity cycle, okay. So your sales and the product maturity. So as the sales is growing, okay, it will come to a maturity stage. Remember the S curve that we were talking about in the beginning? So this is that S curve, right? Where it has matured and then it will come to a point where a new technology is going to take over, right? And the new S curve, and this product will go towards obsolescence, okay? And that is the end of it. So this is where another kick will have to happen to create the new product, right? And a new S curve will start again. Its journey will start like this. Okay. Okay. So obsolescence will never become obsolete. So everything will become obsolete automatically. So the suggestion is that we have to keep innovating. Okay. So with this, I have come to the end of this session. Okay. I know that I had to skip a lot of other slides. Okay. And which may not have been of much of your interest as well, because this is an introductory session. Okay. But I am here to take any questions or any suggestions that you want to discuss.
Yeah.
Thank you so much, sir. Thank you, sir, for this insightful and inspiring session. Your journey from leading global roles to co-founding Z-Centric and now diving deep into the AI and customer experience truly reflects the power of the innovation, adaptability, and vision. What stood out today was not just a vast industry experience, but your deep commitment towards education, transformation, and human-centric growth. It's rare to someone speak with such a clarity about the intersection of the technology, business, as well as the social impact. On the behalf of everyone, here I extend a heartfelt thanks for talking the time, share your knowledge and perspective with us. We are walking away today with the valuable insights and renewed sense of the purpose. Thank you once again, sir, for being with us and inspiring us. Your concepts like NDP cycle, product diffusion model, and the product life cycle model, as well as the golden rule at last you have told, is really inspiring. As you say, keep innovative, that means never stop. Thank you so much, sir.
Thank you. And any questions anybody
Thank you.
has?
Yes, I'm saying that. Now I would like to open the floor for the short question answer session. If anyone has questions for Mr. Arjit Chatterjee sir about his journey, the role of the AI in customer experience, product development, or anything else he touched upon, please feel free to raise your hands and set up the mic. Let's make the most these opportunities to engage with someone who has truly been at the forefront for innovation and leadership. I would like to open the floor for the participants. Participants, please ask the questions if you have any doubt in the chat box, as well as you can start your mic and ask the question. Dear participants, you can ask the questions in the chat box as well.
Hmm.
I think so. No one is no
Yeah,
one
yeah.
has.
Yeah. I guess this is something out of the regular, training that, we will have. So it will take some time to absorb this. Okay.
Sir,
Yeah.
I have a question.
Yes.
Deepak Sonone sir has raised a hand. Deepak sir, please ask the question if you have doubt.
Hello, sir. Good evening.
Hi,
Sir,
Deepak.
I wanted to know about sir market how we can avoid marketing myopia, sir, like BlackBerry in service sector.
See, I would not say it is a marketing myopia.
Mhm.
What happens is that many times, we are also into business. Many
Right,
times, what happens is that you keep listening to your customers so closely that
right,
the customer, keeps your product or services in his, advantage. Okay,
right,
but at the same time, a new set of customers are arising. Okay,
right,
and we will be missing those customers because and that is what no, Steve Jobs had told also, that it
right.
is not always wise to listen to your customers. Okay,
Yes,
you observe your customer, but don't get carried away by what your customer, because what people essentially believe that whatever customer is asking, if we make it, then customer will buy it, right? So in that excitement, we are all creating what the customer is asking for. Okay. But
right,
at
sir.
the same time, there are new set of customers, and you've given a very good example of BlackBerry, where BlackBerry was focusing the corporate users, okay,
Right,
who were using a encrypted way of sending official emails, okay, using the phone, right? But a new set of consumers were arising at the corner, okay, who wanted more fancy thing and do all those things through a smartphone. And BlackBerry was completely not looking out that customer segment itself, okay,
right,
right? And you will also realize that BlackBerry coexisted for a long time when iPhone was introduced and iPhone was popular also. Enterprises were not still ready to take our iPhone because they were thinking BlackBerry is much more secured way of communication. So
right,
my suggestion is that, and it's not like I am a Gyani on this subject. Okay, we also do mistakes like that. But I always keep telling that listen, observe the customer, listen, don't get carried away by listening to them too much. Okay.
right, sir. Thank you, sir.
Yeah.
Thank
Yeah.
you so much, sir. Thank you so much for answering
Sir,
Mr. Deepak's doubt.
excuse me, sir. I am having one question.
Please.
Uh, how can AI identify emerging market trends, sir?
Uh, see, I will say that, what AI is currently doing what, see, if you see large language model, okay,
Yes,
large language model is principally fed by billions of data points, okay.
yes, yes,
So it is actually regurgitating what is already there, okay.
yes,
Maybe
yes,
we are not able to see it because we are not looking at, say, 8,000 billion points, okay, but they are not creating anything new. It is no restructuring and packaging it, and it looks like it's completely new to us, okay. So coming back to your question, how can AI predict? No, AI cannot predict like that, okay, the emerging. But your questions to AI, okay, can lead to finding the research, right? You can use the research capability of AI to find out that this kind of segment or this kind of industry, what kind of solution that they are looking for, or what kind of things that they are using. Okay. So for example, I will tell you, like in cooking. Okay. Now everybody knows that this is something with robotic and with computer vision. Uh, if we have some automatic food, maker, right? So we don't have to get into the kitchen and cook anymore, right? So this is a problem. How big is the market? No, if you start building it, right? How
Yes.
big will be the market? So these are the things that comes with your research, okay? Which AI can definitely help. Okay.
Yes. 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 Thank you, sir.
Yeah.
Thank you
Okay.
so much, sir, once again.
Thank you very much, sir.
Yeah. Yeah. Thank you. And feel free to ask or any questions. I put my email ID. So in case some guys have afterthought and say, okay, I did not ask any question. Can I? So you can feel free, okay, to connect, interact, and it's as you said that learning is continuous, okay. So we cannot say that no, we have become expert in this. I am learning every day in this space also. So if you have
Yes.
something more to share, let me know. Thank you very much.
Thank you, sir. Thank
Thank you, sir. Thank you very much.
Thank
Thank
you
you,
very
sir.
much.
Okay. Thank you.
you. Yes. Now we are moving towards our next section. We are lucky to have Mr. Rajsekhar Uchil with us today. On the behalf of the Shri Barasaheb Mane Shikshan Prasarak Mandal, a Shukramane group of institutions, it's my privilege to welcome a distinguished industry veteran and thought leader in the field of the engineering and industrial automation, Mr. Rajsekhar Uchil from Deputy General Manager Technical at Frost Engineering Limited on the occasion of the smart sensing technologies, design, selection, and applications in the industry. Mr. Uchil is an electronics and computer communication engineering graduate from the prestigious KREC Surat class of 1994. He further expanded his expertise with an advanced diploma in marketing and management from IGNOU. With an impressive 40 years of the professional experience, Mr. Uchil brings deep knowledge in vibrations and acoustics, sensor technologies, calibration systems, and the analysis. At the Jost Engineering, he currently leads all the technical marketing support and macro activities, playing a critical role in bridging the technical innovations with the customer-centric solutions. His past roles include impactful contributions at the Ithorm Dell India as the marketing manager, process and the motion control at ARC Advisory Group in business and development. We welcome you, Mr. Uchil, sir. Can you hear me?
Yes, thank you, madam. Thank
Yes.
you for the very
Welcome, sir.
introduction. I will just start my presentation.
Yes, sir. You can start.
You can start, sir.
Yeah, so I've shared. Is it coming? So,
Yes, sir, your screen is visible.
yeah, okay, right, yes.
Yes.
So, what I'm looking at is talking of new technologies which have come and how they change uh, from what is called the old analog technology to a smart technology. It's like on the mobile phones when we look at the old Nokia 3310, and then uh, today all the phones which are considered smart, whether it is Redmi or Apple or all of them, all the future phones today are considered as smartphones, and they bring a lot to the market. So in the same way, in case of sensors, what is it that they bring to the market from the old to the new, and how is the technology sharing? How is it moving? So that's what I'm looking at. So I'll just change the slide 1 second. So what do you mean by a smart sensor? They
Sir, sorry,
provide,
excuse me. Sorry
yeah,
to interrupt you.
yes,
Can you make it full screen?
yeah, I'll do that 1 second, yes. Okay,
No, sir. It still shows
one
small.
second. I'll stop it and then restart it 1 second.
Yes.
That's what happens when you know.
Okay.
I have found that in Google Meet that when you do this,
Okay.
okay, now I go back to okay. Can you see it?
Yeah. Okay, sir. No
Yes.
issues.
Yeah, okay. So as I said, okay, I'll go back to the smart selections. I'll go back to the slide because I can't see it here when I, put the screen here. So if there are any questions, the presentation is fully interactive. So I would like more questions as they come.
Okay.
Yes.
Yes, sir.
Yes.
Okay. So when we say smart sensors, what do they do? You are talking of some sensors which can give information right in the field before it comes all the way to the control system. So earlier you had a thermocouple, you had a transmitter which converts it into 4 to 20 milliamperes. It runs on the cable, goes to a PLC or a DCS, and then the control system had to take all the decisions. So now you are talking of a decentralization, different systems architecture for devices and manufacturing, plus the whole testing process and monitoring changes. So when we look at a smart sensor, you take a normal analog sensor, so you take a thermocouple. It just gives you a continuous output signal, but no conditioning. So you then have a conditioner in front of you. So whether it's a thermocouple, an RTD, an accelerometer, a microphone, you have to condition the signal, you have to give the power supply, and you have to amplify it. So that's a basic analog signal. A digital signal, yes, some improvement. So you converted it into a discrete binary value. So you have certain amount of filtering and scaling at the sensor level. The smart sensor takes digital technology to the next level. So you have signal processing, analyzing, interpreting, and certain domain-specific calculations automatically in the sensor itself. So for example, in the thermocouple, if I could incorporate automatically the signal linearization and correction at the sensor level instead of waiting for the conditioner. So now that becomes a smart sensor. So it integrates the sensing, the signal processing, and the communication into a single unit. So you have all the linearization and compensation algorithms built into the sensor. You reduce measurement uncertainty, performing fitting, and then you use no longer are you using your 4 to 20 milliamperes or 0 to 10 volts. You are talking of a bus. So IO link, CAN bus, industrial Ethernet protocols. So that takes the signal from your sensor to your main control room. You can take, for example, the old technologies, the strain gauge. The traditional setup, you had the sensor, a Wheatstone bridge, external voltage supply required, amplification required. The signal conditioner does all that. Then you take an analog output or maybe a serial or industrial Ethernet at the conditioner level. It then goes to a PLC or SCADA or on the cloud. So you now have so many different elements in the chain, each performing its own processes. So you have the analog measurement chain was very robust. Sensor and amplifier are tested. They are very fast performance, a good bandwidth. Say, for example, a sensor, strain conditioning sensor, bandwidth of up to 2 kilohertz. The sensor is fully built. It's IP67 EMC tested. You have normally the 4 to 20 milliamperes or 0 to 10 volts in the field. This is the normal analog signal. What have we now changed? You have a digital sensor. So all your limit switches, detection, everything is directly built into the sensor. So your limit switches, peak detection, sensor monitoring, linearization, temperature compensation, all this is now built, as you can see here, inside the sensor. So you have better accuracies and better control at the field level. So smart sensors integrate the sensing element, conditioners, and communication interface into a single unit. So as you can see from the left side, it could be strain, force, load, torque, vibration, sound, pressure, displacement, optical fibers, or any of these communications. And then you have the sensing element, you have signal conditioning, which includes your power supply, amplifier, ADC, calculations, and then uh, digital output, for example, the IO link. So that's where it becomes a complete smart sensor by itself. Yes, any questions? So this is an example of a smart sensor force, everything built inside it. So you have a Wheatstone bridge, you have an ADC inside, you have scaling done inside, you have signal conditioning done inside, you have a peak detection, you have characteristics, the database, everything built into the sensor, and then it goes out as an IO link. So what is the advantage of the smart sensor? Setting up is very, very easy. So sensitivity, load limits, serial numbers, everything is there. It's completely plug and measure. And therefore, at your main PLC or DCS, you could read all the data instantaneously. You don't have to check the sensor. Your complete sensor, serial number, calibration data, everything comes to your control room. When was it last operated? What was the largest measured value? When was it last calibrated? All this information can be read in the control room itself. Also, if the sensor is going bad, for example, by chance, if the temperature was calibrated for 150 degrees, but the temperature is going harder, 160, 170, you get an alarm at the control room itself saying that, please note that the sensor is being exposed to high temperatures. Please do something on cooling it. There is a cost benefit because no amplifiers, no cabinet, nothing. All this warning comes to you on your computer. Also, the compensation is built into this electronics. You also have your linearization. You can create a perfect correction of the characteristic curve, and any other corrections that you would actually do when reading are done at the smart sensor itself. No cable effects because this is all digital transmission, so you don't have to bother about EMI, RFI interference or anything. So these are some of the advantages of. You also fact that an event warning in case of any problems on the sensor. The sensor is comparing the actual forces and temperatures. All sensor characteristics are built into the sensor. So your heartbeat of the sensor goes to your control room and tells you what is happening and no one can change this. This is built into the sensor, and you could get alarms at the field or in the control room on the problems of the sensor. Everything, as you can see, pre-processing is inside the sensor. Digital outputs, limit switches, peak value detection, rotational speed, limit switches, weighting filters, algorithms, all these calculations are today part of the sensor itself and the sensor health monitoring. So these are examples of how these were designed. So for example, the vision was to have smart machine components, which you could analyze process and component states and translate this data directly for the user. As you can see in this flow train, we're talking of acceleration, RPM, torque, force, temperature, thrust. All of these are parameters which have to be measured. How do you take all these measurements and convert it to the user in user and addressable language? So what was the challenges? You had the size of the sensor. How do you run the cables, the point of action, and then integrate all these sensors at the point of interest? Second is it has to be miniature electronics. It has to be easy to configure. So these are challenges that were faced when such smart sensors are developed. So you integrated the sensor, force and torque measurement. Electronics went inside the body. You have an app which gives you on a mobile all the details. You have a gateway to the process control. So this is how a smart sensor is designed for field applications. And then it could go inside a spindle, it could go inside a conveyor, it could go inside a shaft. The sensor as a complete body could be incorporated into any of these mechanical fittings to give the process data to the mechanical engineer. Then you have the communication. So you have wireless sensors based on Bluetooth, simple configuration on the mobile itself. You could have up to 4 sensors, strain, acceleration, RPM. So this is the way that a smart sensor is actually being developed. You then have what is called as edge computing, which means that the data is at the field itself. Any process faults are sent right at the point of occurrence. Your mobile occurrence means even at your home, you get an alarm if something is going on. You then have a gateway which transmits the data digitally to your main control system. So this is some of the, again, the challenges, because you have to integrate the sensor before you close the shaft. So you have to weld it inside. How do you put it inside? How do you seal it? How do you do the temperature monitoring? So this is the final sensor. So you are looking at the temperature sensor on the PCB, and then designed. Then again on roll forming, creation of a profile. So what is it that you measure? Force and torque. You can't retrofit it. It's a very harsh environment. So cabling is not there. It has to be wireless. These are lots of the challenges that are faced when you design smart sensors in the field. And this is what, as a designer, you have to understand what is the constraints. And then what are the problems? Energy efficiency, we don't know the torque. Then what is the time for setting? All this goes into the sensory. These are all examples now that were practically made based on all these designs, applications. You designed the sensor so that your objectives of process monitoring, detection, and energy optimization is met. So now we are looking at the torque calculation straight away. Just an example. Where are the places that these are used? Your overload protection in your tractors, your lifetime assessment, your wear protection on your valves, predictive maintenance, on your fitness, on your gym, on your process. These are anything that you can think of today. You could put a sensor there and it measures your information. So what's the challenges? The demand on process monitoring and optimization. What are the solutions? You integrate the sensors in the machine. You have miniature electronics today. You use MEM sensors. You have a small IC which does the communication. You also have a mobile application so that you get data in the field. You cannot sometimes stand near these machines. So you could stand away and your mobile could read all the data. Retrofitting is easy. Data analysis and interpretation becomes very easy. So these are some of the examples of smart sensors. Now we go on to a little on the communication. So the IO link is just one of the many communication parameters being used. So for example, many of you would have come across, Modbus, Profibus, Foundation Field Bus, HARP. So IO link is one of the other standardized technology protocols. It meets the IEC standard 61139. So you have devices, masters, IO device. It is an open standard, so you can integrate it with all the other Ethernet protocols like Profinet, Ethernet IP, EtherCAT, Modbus, CC link, Power link. So your IO link can talk to a PLC with any of these communications also. So it bridges the field level with automation. It's a single cable operation, cable connector, and single unification, and it's a established standard. So it's not something that is so unique that it can go only to your system. And that's the advantage or demand of the market today, that your system has to be open. So any controller, I could have a Siemens PLC and I could have a smart transmitter from, let's say, Endres and Hauser. Can I talk to each other? That's the requirement. And therefore, protocols like IO link are open. You could get an IO link to Profibus converter and take that sensor into a Siemens PLC or a Schneider PLC, depending on the protocols. And you have lots of bridges today to convert one protocol to another. So you have a link efficiency, as you can see here. You have IO link at the sensor level. You then have a master, which is industrial Ethernet independent. So it doesn't matter what Ethernet protocol you are using. You have an engineering tool to commission it and visualize it. It goes to the PLC or it goes to your IT/OT integration. So you have sampling also very high, 4 kilohertz bandwidth for pre-processing, and then the very fast speed, 100 hertz bandwidth, 300 microseconds runtime filter, device master. What is the advantage of these? No cabinets, no amplifiers, very price effective, standard cables, plug and play sensors, and the same architecture in any field bus environment. So for example, I have a plant with an ABB DCS. I have a plant with a Siemens PLC. I have a plant with a Schneider PLC. You take any standard smart sensor with regular interfaces like IO-Link or Profibus, and it can talk to each other. Your configuration becomes that much easier. Otherwise, for each one, you have to sit and write your programs. You have to do your configuration, HMI, everything. So that's the trend that the market is talking of, all smart sensors. Okay, so that's the quick thing. I ran through this presentation quite fast, but I would like to make it more interactive and discuss with you on where do you think smart sensors are evolving in the market. I know I rushed through the presentation, maybe 25, 20, 30 minutes. The whole idea was that this is presentation, this is theory, this is practical. I will not say theory. These are all standard products available in the market, but I would like to take questions from the audience on how we can, look at technologies. These are all today building blocks of what is known as Industry 4 or today Industry 5. So the sensor to boardroom, which is the second part, which I'll take tomorrow. But the smart sensors are the building block of what we talk of a sensor to boardroom approach. So almost any parameter in the field can be detected by the sensor, and all the costs of incorporating a smart sensor are offset by the amount of advantages you get in the final. So your ROI is much better in an overall investment. A best example would be, even 10 years back when Reliance put field bus sensors everywhere, it was one of the largest installations of foundation field bus anywhere in the world. I think this was at the Jamnagar plant where more than 3,000, 4,000 foundation field bus systems were put. So the advantage is at the control room or on your mobile, you can get all the process data going on and all the calculations done. So if you say that the temperature is going high, the pressure is going high, also your MES can do the calculations and find out what would be the effect on your material if there is a change in the temperature or pressure. An example would be, you would say that at perfect control, I'm taking a material and the price is 100 rupees. Let's say 100 rupees per gram. During the process, if something goes wrong, now if the item is in the oven, you can't change it. But you have known that due to variations in temperature or pressure, your output quality is not going to be 100, it's going to be 90 rupees. So you tell your marketing people that, look, the product is going to be at 90 rupees. You tell your finance man that my financial outlay is not going to be 100 rupees. Output is going to be a 90 rupees output. You tell your salespeople or you tell your dealers that, look, I have a large product, but it is not the top grade. It is at a slightly lower price, maybe slightly lower specifications, but that's the whole trend. And that is where now all this trends of ISA 95 and others come, MES, where data goes right from what's happening to the field, right to the dealer, right to the CEO of the company in real time. And that is where the smart sensors are the building block of such technologies. Yes, any questions, please?
Excuse me, sir.
Yeah.
Sir, I'm having a question. How to choose the right sensor for specific applications?
So let's look at it from your first principle. So like when you are measuring temperature, you have temperature ranges. So if you are doing, say, HVAC application, you would normally use temperatures with a small temperature range, very small place to keep it, but a temperature and a very normal atmosphere. So the typical thing would be RTDs. If you are using in a plant, then if it's high temperature and not a bad environment, you could use J or K thermocouple. If it is high temperature at 2000 degrees, you would use R and S. If the environment is acidic, then you would use something like N. If it is a temperature where you cannot contact, so for example, transformer or steel plant, you cannot put a thermocouple at 3000 degrees in molten steel, nor can you put a temperature sensing element or a transformer at 66 kV. You would use infrared sensors. So that's your selection of the sensors. So in the same way, pressure, same way vibration. So for example, if I'm doing vibration monitoring, if I'm doing a vibration monitoring on a PCB, the sensor has to be very, very light. If I'm doing the sensor monitoring on the ground, the weight of the sensor doesn't matter. If I'm using it on a gas turbine, then I'm talking of temperatures at 400 degrees centigrade. My vibration sensor has to operate at 400 degrees centigrade. If it's a nuclear power plant, the sensor has to be nuclear hardened. So I'll have to get sensors which can operate in very high radioactive fields. So these are, for each sensor, there could be 10, 15, 20 parameters that you would select, and you do a trade-off that how important is which parameter at that time of operation. It could be the space, it could be the weight of the sensor. For example, an accelerometer mounted on a PCB in a spacecraft has to be even less than 1 gram or 2 grams. If I'm mounting it on a generator, it doesn't matter. It could be 20 grams because the generator weighs a few tons. So your weight criteria, your temperature criteria, all. So similarly, if I'm monitoring pressure or flow, if I'm monitoring flow, is it intrusive or non-intrusive? If I'm talking about turbine flow meter, I will have to cut the pipe. So very difficult to do it in retrofitting. So I would then prefer to do an ultrasonic flow meter, which can be put outside the pipe. However, does the pipe material and the liquid be conductive enough for ultrasonic is another application that has to be considered. So I could take a full session on sensor selection, but these are topics that I would take. Depending on what you are measuring, the sensors classification, criteria, calibration. Can the sensors be calibrated? That's a very, very important topic today, because everyone wants to know whether, how do I calibrate my sensors? Is it something easy to calibrate? Where will I calibrate? Which lab can I calibrate it? So you will have to take sensor criteria for that also.
Okay, okay, sir. Thank you, sir. Sir,
Hello, sir.
can we call these are the challenges in designing multi-sensor systems?
Yeah, the thing is, when you are talking of multi-sensors, then you would have to have conditioning. If I take an old analog method, you still have conditioning for each. So you take a comparison between a thermocouple and an RTD. A
Yeah,
thermocouple J or K type just gives you a voltage output. So you require a conditioning amplifier. You require to amplify the signal. You condition it and you read it in your simple display. Now, when you take an RTD, it is different because you have to give power to the RTD. So your conditioning circuit changes. So to put both of these in a single board is not very easy. You do have, for example, a temperature data logger today is universal. So you could connect thermocouples or RTDs. You will have to configure it up front.
yeah.
But obviously now the same thing cannot be used for, say, a microphone or a accelerometer, because the accelerometer normal output is charge, else it is an ICP sensor. So your front end of your data acquisition system has to support an ICP input. Or a special microphone, you require 200 volts polarization at the front end. So now one is you selected the sensor. Second, when it goes to the data acquisition system, will the data acquisition system be able to do what the sensor wants? So that is your matching. So when you have tried to put all these universally, it's not very easy. So you will have a trade-off. So you could have thermocouples maybe in one, you could have microphones and accelerometers, a separate module, but then they could all be taken on a digital bus, and then your data comes together. Another important thing is sampling. So noise and vibration sampling is very, very high. So we do measurements at 20 kilohertz. So you have to sample it at 2.5 times, so 60 kilohertz, 70 kilohertz. In case of process parameters, you don't sample it at this high speed. You're sampling it at 2 hertz, 3 hertz, or 4 hertz. So your conditioning circuits for both of them have to be in two separate parts, because vibration and noise, you look at the time domain and then you convert it into frequency domain. You don't do this in the process parameter. So the entire conditioning, the entire processing, and the entire display changes.
Yes, yes. Okay, sir. Okay. And sir, one more question, please.
Yeah, please, no problem.
How do embedded systems enhance sensors functionality?
I'm sorry.
How do embedded systems enhance sensor functionality?
Yeah, so this is the way back that I said, when you have the smart sensors, you can take an example, that's an embedded system. So you have all that into the sensor itself. As I went back to the first slide, all your sensors, all your information is now inside the smart sensor. This is your embedded sensor. So your peak detection, your filters, your traceability,
Yes.
your algorithms, everything is inside the smart sensor, and you're getting only a digital data output. So
Yeah.
your controller is taking only, say, an IO link in this case.
Okay.
So the challenge is, how do you put all this in the field? And reading the data then becomes simpler. The design of the sensor becomes that much complicated. So that's the way I
Hello,
look at
sir.
it.
Hello.
Yes,
Hello.
I think there is some background noise. May I request people to mute their mics, please?
Yes, yes.
Yes.
There is one question from the participant, Dr. Vishal Wadkar. Are there specific case studies where smart sensors significantly reduced energy consumption?
Uh, I have not looked at energy per se on this, because the energy is also related to your process parameters. So, for example, now we use variable frequency drives for fans and pumps. You know that fans and pumps follow the Cube law. So, if you decrease the speed of the fan or the pump by, say, 20%, your energy consumption comes down by 50%. If you have a sensor which continuously monitors the speed, your variable frequency drive can also give you your energy output continuously. It's possible.
Yes, sir. I have a question. Sir, actually the topic is very relevant to my PhD topic. So when working with the wireless sensor network, the main challenge we are facing is the energy efficiency and the security.
Yes.
So what can you suggest for this?
Okay. The wireless sensors, the one biggest problem globally is the powering of the wireless sensor. So if you put a battery inside it, your normal battery life is maybe 2 years, 3 years. And so therefore you have to decide how do you do it. And many of the wireless sensors today in one way are use and throw, which means that at the end of 3 years, replace the sensor. However, there is also the other criteria that when you put a power device in the field, you have the hazardous area classification. So you cannot put a battery powered device into a say MRPL, petrochemical industry. There are standards on how you can put powering in the field, because you could have explosions if the voltage is high. So that is one criteria of the batteries. The second is your protocol when you are transferring the device on the wireless. You have the standard protocols like the ISA 100 or the wireless heart or the wireless field bus, or companies using their proprietary protocol. Also in wireless, you have something, for example, self-healing mesh network. So you have the data coming from the sensor to a number of conditioners parallelly. So if any of the conditioners go out, it doesn't matter. It selects another path and goes by itself. And then at the end, you also have an important thing is security. Today, if you are talking of process plants, then one of the most important things coming up is the IEC 62243, which is OT cybersecurity. So is your wireless network secure? Will it be will someone be able to hack it? Is it a one-way or two-way communication? If it's only reading, no problem. But if it is a method is there to write back, then it becomes very dangerous. So you will have to consider that. Also, in an actual plant, is it line of sight? You have a problem that many of the wireless sensors operate on line of sight. You may not be able to get line of sight inside a metal plant. A steel plant, the other big problem is because of too much metal around, you could have a lot of interference with the wireless networks. So mounting of the wireless network sometimes takes time in practical considerations. Theoretically, it's very easy, but all these practical considerations come in. Also statutory requirements. So for example, what is the band allowed in India for communication. It may not be the same as what is used in Europe or USA. So a designer has to check what is the frequencies that are allowed in that country, get permission for that particular. If that band is free, then there is no problem. If it is bands which are being used by, say, space or defense, you might have to get permission to use that frequency. So these are also actual practical challenges when you use wireless. Is good, but also understand how it is. You don't want a wireless signal that is coming from your transmitter to get interfered, say, from your radio signal or your mobile signal. The best example is you get into a plane and they say switch off your mobile. Why? Because your mobile signals might interfere with your plane signals. So in the same way, when you have a wireless signal in the plant and someone is operating a mobile nearby, will it get interfered either way? Will it disturb other communication systems in the plant? All those have to be considered. There are full notes available, and two particular consortiums where I'm well aware is the ISA 100 Wireless Consortium for wireless selection criteria and the cybersecurity IEC 62243 for OT cybersecurity when you are using any data like this.
And then, sir, how to select the protocol for energy consumption to get maximum energy for the communication?
I'm sorry, I couldn't catch. Are you talking of the energy consumption on the signal or the energy of the process?
Energy of the process only, while communicating from one sensor to another.
I will just give an example. We installed VFDs in Indal, Belgaum some years back.
Okay.
Now, what happens is one of the reasons why VFDs are used in the process is because when you are using with fans and pumps, they follow the Cube law. The Cube law means that if you decrease the speed of the fan from 100% to 80%, your power consumption drops by 0.8 into 0.8 into 0.8, 50%. Now, what also Indal was doing is the drives had a PID loop, and the pump, it's like filling the tank in your house. Your pump speed could keep on decreasing as your tank gets full, right?
Yeah.
So that is the PID loop which is operating inside this drive, so that 110 or 140 kilowatt pump gradually decreases its speed as the tank gets full. And the signal also goes to the DCS saying that yes, the tank is full, processes will start. And in a process plant, the tank gets continuously, consumed also. So you will have to adjust the pump speed to ensure that, say, your tank is always 70% full, never drops below 40%. So you have alarms. You also want to do it very slowly so that as it hits your peak level, your drive speed comes down. All these energy calculations are done in the drive, and the data can go to the control room. The similar applications in HVAC, you have hundreds of chiller pumps and fans for your air conditioning system. Now, you don't require the same cooling capacity in summer or in winter, right? So what do? You measure the temperature of the water, inlet and outlet temperature, and keep changing the pump speeds. So if it is winter, then you don't require the pumps to operate at 100% capacity. You operate only at 50% capacity, and you get a good power saving there. At peak summers at 48, 49 degrees, the pumps are running at full speed. But again, once your room temperature is stabilized, then again the pump speed automatically comes down. So these are all control systems which change on the energy conservation. The latest development today is the new system that is put by Adani, where it is not one group of pumps or say individual pumps for each room. He has sort of put a group of pumps, and only the water supply goes to the each buildings. It's a different chiller concept. It's a distributed chiller concept, which saves a lot of power again. You have building management systems which do all this energy monitoring automatically. And today, with the green buildings, energy is a parameter which is automatically given importance, and you get the classification of your buildings also on how much energy you save. So you have it in building automation. You also have it as a PAT criteria in many plants. So all high energy consuming plants have been asked to adopt energy conservation technology. So fans, pumps, heaters. So your heater control systems, thyristors today are PID control. So your heating reducers rather than a single. So each process people study and say, okay, where is it consuming power? Can I change the speed? Can I monitor the parameters and keep on decreasing it? And then you adopt measures where you, for example, conserve the speed, you recycle the hot water for anything, for reuse the same heat content of the water. These are all different techniques, but which are all computerized, and data can come out almost on a continuous basis on the power consumption. And you could then monitor it and say, yes, I'm reducing power by so much. I hope I could clarify some of your points, sir. Hello? Hello?
Yeah, yes, sir.
Yes.
I mean, energy conservation and monitoring is a huge topic by itself, but these are small examples of what I've given. You take a college classroom, you take a lab, and you discover that in a huge lab there are too many bright lights all over the lab when people are sitting there. Instead of that, could you put small sensors in each chair so that when the person is sitting on that chair, the light above the chair gets switched on? Otherwise, you don't require lights in the whole lab if there are two people in the whole lab, right?
Yes.
But
yes.
that will save a lot of power to you.
Okay.
It's very small when you look at it once, but when you look at 25, 30 bulbs burning in each lab, and you have 100 such labs in a college, even if you could save a kilowatt a day, it becomes a huge amount.
Yeah, definitely, sir.
Sir, I want to ask, that is okay if the sensors are accessible, but if the sensors are in some hazardous area or under ocean, in that case, how we can do that energy saving, sir?
I mean, so the sensor being in a hazardous area is only the process part. So all petrochemical industries, the sensors are in many cases located in the hazardous areas, but your control algorithm. So for example, a fan or a pump in the chemical plant is process driven. So let's say you don't want a large cooling from the fan. You could have a PID control on the fan, which decreases the fan speed. It doesn't matter on where the sensor is. The sensor will give me the output of the temperature or the pressure or the flow rate, and I modify it as process related. So the location and the hazardous area classification and the operations is quite different. It doesn't really matter.
Okay.
I mean, I could put a sensor inside a steel plant on saying that how much should the steel be heated. Yes, now if I know that the furnace is continuously running at 2000 degrees or 3000 degrees with thyristors, I will have a PID control on the thyristors to ensure that it stays around 2500 plus minus 10 degrees instead of on and off control. So that itself gives you an enormous energy savings. As I was saying, I could switch off furnaces when not required. I could decrease the temperature if the process doesn't demand it. All of these help in the energy savings.
So one more question.
Yes, please.
How do environmental conditions can affect the sensor performance?
I'm sorry.
So how do environmental conditions they can affect the sensor performance?
It's very much. So let's take an example for an accelerometer, which is a vibration sensor. Now a vibration sensor is nothing but a piezoelectric crystal inside a titanium body. Now this is, if there is electronics inside, then the sensor and electronics combination works only up to 180 degrees. More than 180 degrees, the electronics get spoiled. So you'll have to consider the temperature. If it is In an oil-filled environment where there is oil spray, then you should look at a absolutely sealed configuration, so IP68. If you are using it in a nuclear power plant, then it has to be nuclear hardened if it is on the radiation areas. So there are special materials which are used to ensure that the radiation inside the radiation doesn't enter inside your accelerometer. So that's on the radiation side. So you have temperature, you have pressure, you have humidity, you have nucleonic radiation. All of these are involved in part of the sensor selection. If you take a car today and I'm measuring temperature, the temperature inside your cabin is about 25 degrees at 30 degrees. It's a very nice condition. I could use a simple RTD. If I'm measuring engine temperature, which is going to 400, 500 degrees, or even much higher, I would use a different type of sensor. You can't use the same sensor for both the parameters, right?
Yes, sir. So one of the participants asking like what industries benefit most from smart sensing technology.
I would say look at all large process plants where data information is real time required. The benefits are easily quantifiable compared to your old analog sensors. So for example, I gave the example of Reliance, which went into foundation field bus about 20 years back. They discovered that the investment of say 10 lakhs extra easily was recouped within a year with the information on the process that everyone could see. You could sit in your house and see what's going on inside the plant. You don't have to enter the plant. You don't have to call that man saying, sir, is the temperature high? Is the pressure high? On your mobile, you are getting the alarms. And your whole process also finally improves. So where you are selling some material at a cost which is say 75 rupees, if my process improves, the quality of the material becomes say 100 rupees. So once your process is improved, your output quality improves, and the more money that you can make. An example, for example, if you are making high quality biscuits, you put it in an oven which has very high quality, or pizzas and all, which you want it uniform worldwide. They put temperature controllers inside the oven so that you know exactly that wherever you bake the dough, anywhere in India, the temperature is the same. And therefore, you get quality material at an absolute process. So, the moment your process is better, your output quality becomes better, and the price that you can demand for that becomes much, much higher.
Yes, sir. So one more question. How are the smart sensors used in predictive maintenance?
In predictive maintenance, there are two aspects. One is your sensor detects anomalies on the vibration level, for example. You then also have AI and ML coming into the control room, and it says, yes, based on this information, there is a problem in the motor, in the generator. When you do vibration analysis. A vibration analysis spectrum to a mechanical engineer is like an ECG to a cardiologist. The cardiologist can look at your ECG, and if he is a very senior cardiologist, can tell you that, look, there is a problem. You may have to have a surgery today. You may have to have a surgery 3 months down the line or 1 year down the line, right? So you are prepared. So in the same way, our smart sensors with the AI/ML algorithms can diagnose a pump and say, look, there is a problem in the bearing, there's a problem in the oil filter, there's a problem in the gearbox, and you are warned much, much ahead of what could happen. So let's say it's a bearing which is not available immediately, but you are warned that 3 months later there is going to be a bearing problem. So you tell your purchase people that, look, 3 months later I'm going to have a plant shutdown. My software says that these bearings are bad. This gearbox is bad. Place orders right now to the supplier so that when we have a plant shutdown, you have the bearings and the gearbox ready to replace it. So all this diagnosis inside your system, you have, for example, in an automotive today, you have something called the CAN bus or ODB. and it tells you all that is going on inside your car, your temperature, your pressure, your flow, your noise, vibration, everything. Now, if you find during driving your car, say you're driving it on Lonavala at low gears and the car is heating up, this could be a test car. So then Tata Motors, for example, driving the car on those ghat sections will tell the design people that, look, I drove up the Khandala Ghats, and when I was driving at second gear, climbing up the mountains, there was too much noise, there was too much vibration, the cylinders were getting hot. This information then goes back to the design people who find out why you are not expected to be driving at second gear, you are supposed to be driving at third or fourth gear, but the car torque is not getting built up, the pressure is not getting built up, and the car is getting heated. So it's so the design people go back and change it. All your aircraft today, you have automatic health monitoring systems, what is known as the FADEC, which looks at the engine health and continuously gives a feedback to the pilot on any problems, on which engine is open, which engine is closed. You have all the analysis coming out after that last air crash in Ahmedabad, where they said, yes, this line was closed, that line was closed. Your black boxes get all this data, and you can do an analysis later on. And that data in many cases is also today streamed down. When you do a flight testing, all this data comes to the ground station and they look at it continuously and tell the pilot, look, there is a problem in the plane, come down, or don't worry, you can go at high speed. So these are all operational data which gives continuous improvement on the final process.
There is one question from one participant, sir. How the troubleshooting of the smart sensors is done?
So, for example, when you are looking at the smart sensors, you have electronics inside. You take an IC, and many of these, any smart device today has what is called a heartbeat sensor. Your heartbeat signal comes back to your control room, continuously telling you that, yes, my sensor is okay, the voltages are okay, the temperature in the background is okay. All that information goes continuously to your control room as purely sensor troubleshooting. And if at any given time there is a problem, you could say, yes, I could remove the sensor off the line, or that this sensor is giving a problem after a certain temperature. So during a plant shutdown or something, you could remove the sensor. Or if you have two sensors in the same, plant, you could say, okay, sensor 1 is giving a problem, I'm switching it off. I'm now going to switch to sensor 2. This could be manual or automatic, depending on the criticality of the process. If it's redundant, then it's done automatically. Automatically, the computer says sensor 1 defective. I switch off. I'm going to sensor 2. So all that information from the sensors goes to the control room, and I can, show you here. You see all these information that comes on your sensor, your temperature effects, your sensor health monitoring, your sensor load, temperature settings, filter settings. All information comes continuously to the control room, and you could have a separate page which looks only at sensor health. And it doesn't come as a surprise to you because of this data coming continuously. You take an example of your computer. So for example, if the fan is not working in the computer, you get an alarm on the computer immediately saying fan not working, computer will shut down. Or, board getting overheated, computer gets shut down. So what's that? That is all monitoring the health of your hard disk and your motherboard in a very limited way, but immediate information. So anything, all these electronics today do a continuous troubleshooting, telling the user that what's happening. Your temperature is getting heated, your fan is not going, there is a problem in your drive. Sometimes some of these softwares will tell you whether your hard disk writing is going on or not, if your batteries are working or not working. So for example, the Lenovo system that I have, it tells me immediately that the internal battery is not working only the external battery is working. So tomorrow when I tell my computer or my IT man, I will say, look, please arrange an internal battery also, because the diagnosis says that the internal battery is dead and cannot be charged. So these are all what do you call alarm signals built into the electronics today. And all the heartbeat comes to you in a very simple language. I am not bothered about as an end user, I'm not bothered about the type of the battery or what's going on inside the battery. It simply says battery cannot be charged. That's all. So I have to replace the battery. So if for example, we discussed wireless sensors. Wireless sensors have a battery which operates at typically 3 years or 5 years. But if there is some problem, I'll start getting an indication in the control room that's saying battery low, battery low. So maybe then tomorrow I can't rely on that sensor for the control loop. That's just an example of a smart sensor. It tells you what's going on continuously.
Yes, sir. Okay. Sir, one more question, please.
Yeah, please, no problem.
Sir, now in this world, we are hearing this IoT,
Yes.
Internet of Things. So
Yes.
what is the role of IoT in industrial sensor networks?
Yeah, so when you have a sensor which sends data, like your smart sensor, your smart sensor is the building block of an IoT, or more correctly today, industrial Internet of Things.
Yes.
So your smart sensor data all comes to your control room, both in the terms of as I told you, the sensor health, the process parameters, and what's going on the data. So for example, if I've switched the PID loop control, the sensor tells me, look, I have changed the PID control. This is the information. So all your data, and when you are talking of sensor to boardroom, then right at your control room, or even as I said, on your mobile in your house, you get an alarm saying, yes, sensor defective or sensor control loop not working. Or if it is multiple sensors, like you said, one sensor defective, can I change over? Automatic redundancy has switched over. But tomorrow when the maintenance is done, you know that sensor 1 has broken. The plant is running only on sensor 2, which is sometimes a dangerous situation, because you expect redundancy. So nuclear plants, process plants, space industry, you get all these indications immediately that there is a sensor defective. I can't use it. I will have to, rely only on one sensor. So what do I do? Then the decision comes, should I shut down the plant, or can I take a risk and run it only on one sensor? All this is part of the process. So for example, in aerospace or defense, maybe they say that no way. If out of 3 sensors, more than 2 fail, you have to shut down the plant. So maybe the aeroplane is asked to come down, saying that we see from the ground that we are getting signals that the temperature sensors in the engine are not working, or the vibration signals there is a problem. Come down immediately, because once the alarm comes, you will not know. So that is where your signal data comes in. Your Internet of Things enables you to get data at your control room on what's going on the process. However, then how is the signal carried? Your data from your sensor, is it on a cable? Is it on a normal industrial protocol like foundation field bus or Profibus? Is it on a wireless, like a wireless HART or ISA 100? What is the type of information that comes on that? How is it interpreted in the control room? Because when you have high information, for example, I go back to vibration. When you are doing high-speed vibration or acoustics, the sampling rate is very high. We are talking of, say, 130 kilohertz per channel into 200 channels of data when a satellite is monitored. Your hard disk, can it read at that data? Your normal Winchester hard drives cannot read. You have to have a solid-state hard drive where all this data seamlessly runs into it at 1 Gbps for even 200, 300 channels. So your entire system design also depends on what is your final process. You also have redundancy. ISRO says, for example, that when the data comes to the control room, it has to be mirrored, which means that 2 computers, the data has to be written parallelly. If one computer fails, all the data will still be in the other computer seamlessly, and I should be able to retrieve it. And I should know when computer 1 failed and when computer 2 only was running. So all this is part of the design. The IoT is just transforming your sensor intelligence into the field, but what happens at your final information is totally your process. How important is it? Your house, how smart is it to inform that something should happen, some protection should be happening? Your let's say you're on the geyser and someone has switched off the tap, your geyser could blow up. So there is a simple pressure switch, which gets activated and your geyser is saved. Now, if you imagine 100 such geysers in a hostel, what sort of protection is there to prevent anything from going? Can I literally switch off one bathroom if I think that there is a geyser problem or that there is no water? Yes, automatically I can get information that one wing of the hostel should be closed because water is not coming. So this is all part of the control system strategy and how critical it is. I could lock off rooms in the building automation. If tomorrow there is a terrorist attack in a building, can I seal off certain rooms so that either he cannot get out or he cannot enter into that room? So that's again part of the control strategy.
Yes, sir.
Can I isolate it? All places they isolate the control systems to prevent anything happening. So it cannot be the complete, any control system should not be treated in isolation. We should treat it from beginning to end and how critical and how important it is. As I said, I work in aerospace and defense, and there the tolerance is zero. The slightest delay or the slightest error means they say it's not accepted. The enormous amount of tests that they do, right from a simple sensor to the cables, even cables that we give them, they test the cables for degaussing. It is a destructive test. If the cable doesn't pass, your tender is rejected. So, that is the sort of testing that is done on space and defense, because it cannot have any error. Your satellite, once it goes into space, you can't bring it down. So you can notice even the tests today that are going on. Last week also there was a testing for the Gaganyaan, where it was dropped from a parachute. They are talking of about 25 tests at each stage, because you are talking of a man inside the rocket. So it is not just that the rocket fails, the person inside the rocket could die. So you want to have multiple tests. Instead of 10, you might do 20 to make sure that the system is absolutely safe for the human being. If it fails this way, is there a second parachute? Is there a third parachute? Can he jump out of the door manually if the height is low? Everything you have to consider.
Yeah. Yes, sir.
I've just given an example of a simple reliability on space. All of you would have seen the connectors used in our computer, right? The back, you have a small D-sub connector, or everyone would have seen it. You buy that connector in the market. It's maybe 1,000 rupees for one connector. It's a high. If it's simple, low cost, it could be even 100 rupees. The same connector mechanically, I sell to ISRO. I sell it and it's 1,000 euros per connector. 1,000 euros is a lakh. Why? Because that D-sub connector has 128 pins, gold plated, guaranteed for 1 billion operations, can operate in space without any problems, and has designed for absolute reliability. And ISRO therefore pays. That's the difference. That in space or in defense, there is no error, absolutely no error. So they pay such a high cost for this connector. Though mechanical, you might think it's the same thing that I put in my computer at 100 rupees.
Yes, sir.
No problem. I think questions when they are asked helps everyone. So anyone who has any questions, please feel free to ask, because I will try to answer to the best of my ability. I may not. There may be a lot of points where I'm not an expert. You can send the questions and I can try and answer it. Ask my colleagues who are experts. But the answer in many cases supports all the 100 people on the call. Maybe they didn't know it. Maybe they have not realized this application.
Yes.
Yes, ma'am. Thank you so much, sir, for sharing your valuable insights with us today.
I hope the information and the presentation was what you expected.
Yes.
Yes,
Yes.
sir, definitely.
And
Yes.
if there is anything else, you can always get in touch with me.
Yes, ma'am. Your talk was not technically enriching, but also great reflection for your 4 decades on hands-on experience in engineering, vibration, and industrial automation. We
So
truly
this is
appreciate the way
my
you
phone number
treated.
and email is here. So anyone wants, they can always contact me anytime.
Yes. Yes, sir. Yes.
Yes, sir. Yes, sir.
A
On the
lot of
behalf of
the
everyone,
institutes may not have, encountered industry problems, and that is what I try to address.
Yes.
yes, sir. Yes, sir. Yes, sir. On the behalf of everyone, we extend a heartfelt thanks to you for taking the time to with us and delivering such a thoughtful and impactful session. Once again, thank you, Mr. Gil, sir. We look forward to learning more from you in future.
No problem. No problem.
Now, yes, sir.
Anyone
Now I
can
would
get in
like to
touch with
open the
me.
floor.
I'm available on.
Yes, sir. Now I would like to open the floor for question and answering
Why I'm
session.
willing to come also in Bangalore, no problem. Out of Bangalore, yes, not impossible, but definitely I'll be happy to come anywhere.
Yes, sir. Yes, sir. Thank you so
Yes.
much.
Definitely.
Right, madam. Thank you very much.
Yes, sir.
Thank you, sir.
Thank
Now
you,
I
sir.
would like to ask the participants if you have any doubts, please feel free to ask. You can raise your hand through chat and you can message us also in chat. Participants,
Yeah, so someone was asking algorithms used for sensor health monitoring.
Yes.
Yes, there are algorithms. Now the question is, what is a sensor that you are looking at? If you are looking at a temperature sensor, then you know that, let's say, take a very simple thing. You have a K-type thermocouple. You know the linearization and the voltage which should come out for a K-type thermocouple. Is that coming at your control room? When you convert your digital to analog data, am I getting a clean data on the sensor? So that's okay. You have another example when we use microphones for monitoring. So I can send a signal to the microphone from my control room and check each microphone that it's working, and I get back. This is known as a CIC algorithm, which is used in all pollution control. When I have 30, 40 microphone monitoring systems all over the city, then I could send signals from the control room to the microphone, and it comes back, and I check the whole loop and say, yes, microphone in station 1 is okay, microphone 2 in station 2 is okay. So the answer is yes, but the question is which sensor and what in parameter are you checking for the sensor?
yes, sir. Thank you so much, sir, for answering this question. Participants, I will ask you questions. If you have any doubts, please ask. Yes, sir. Thank you so much, sir.
Yes, so if there are any other questions, you could always send it across later on.
We will wait.
And you could send it at people who are there, participants. You could send it to the college in Kolhapur. Shreya madam and others could collect it and even collect it to me later on and send it also. No problem.
Yes,
Yes.
sir, definitely.
So, because what
Yes.
happens is you are talking of a huge topic which you are trying to cover in 1 hour.
Yes. Yes, sir.
Yes,
Yes.
yes, yes.
Yes.
Before we end, I would like to thank everyone for your active participation today. Your input and engagement made this session truly valuable. Thank you for your time and contributions today. We look forward to seeing you at the next session. Have a great rest of your day. Thank you so much, everyone.
Thank you. Good night, everyone.
Thank you very much, sir.
Thank you for your patience for staying so long.
Thank you, sir.
And so it was interesting. Thank you so much.
Madam is also from Kolhapur.
Yes, sir. We are faculty of Ashok Mani Group of Institution.
Okay, both electronics department, is it?
Yes, sir. Yes.
Okay, no problem. In fact, I was talking to your colleague also. At a
Yes.
mutually convenient time, maybe I will try to come to Kolhapur also. No.
Yes, sir. Yes, definitely.
Okay. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Participants, the feedback link has been shared in the chat. Yes, ma'am?
Yes. It is provided in chat.
Chat box. Please fill the feedback link.
पाटील मॅडम
Yes, sir.
मॅडम ते चॅटबॉक्स मध्ये मला चॅटबॉक्स दिसतच नाही माझ्या याच्यावर लॅपटॉप मोबाईल वरती
कसं काय, sir?
काय माहिती तेच बघत होता आता तुमचा मेसेज वाचला मी
Okay, sir. We'll provide in our WhatsApp group.
ओके थँक्यू ओके थँक्यू
Yes. Thank you all.
असाइनमेंट्स कधी मिळणार आहेत?
सर लास्ट डे ला एक एक्झाम असते MCQ टाइप. हा 30 तारखेला आपला सेशन संपतोय ना, तर 3 तारखेला आम्ही क्वेश्चन देतो ते सगळे
सगळ्या टॉपिकचे असणार?
सगळ्या टॉपिकचे असतात. एक 30 क्वेश्चन असतात. MCQ बेस्ड असते ती क्वेश्चन हे एक्झाम.
ठीक.
येस. ओके.
Participants, I would like to remind you again about the feedback link. The feedback link is in the chat box. If you won't find it, you can contact us.
Feedback link is provided in WhatsApp group also. You can take it from that group. Yes.
Yes, sir. Yes, ma'am. Okay.
Okay, madam. Shreya, madam.
Yes, ma'am.
We'll leave the
We will
meeting.
leave the session.
Yes. Okay. Thank you.